I use Delling WDQN algorithm with prioritized experience replay to work on the Lunar Lander project. The goal of this project is to successfully land the lunar lander on designated area. There are 8 states for actions for the lunar lander. The environment, such as the reward policy and the termination conditions, are also summarized in this table. For the DQN algorithm, first we initiate the state and episode reward value, and then choose an action while reinforcement learning according to the current state. Then update the episode reward and store the transitions, let the agent learn. We need to check if the episode has ended. If not, let the next state be the current state and then goes back to the loop. One difference is that we need to store the transitions. Another difference is that the agent learns in a different way. I use Delling DQN and prioritized experience replay. To achieve the double DQN, instead of getting the largest Q value from the neural network Q value pool of ST plus 1 directly, the action index was identified from the neural network Q value pool of ST plus 1 first, and then select the neural network QT plus 1 value based on that action index. Regarding to the Delling DQN, additional networks for advantage and the value were created. To achieve the prioritized experience replay, a memory class was created to store the transition in some tree data structure. To sample the batch according to the priority and update the priority when new data was added. Here is the result. Relationship between the accumulated episode reward and the number of episodes for one trial with epsilon equals to 0.95 and gamma equals to 0.99 and alpha equals 0.0001. As we can see, that at the beginning the reward is very low because the learning process just begins. From episode 400, the reward begins to increase, and the reward increased to 200 at episode 500. Though there are some vibrations, the reward gets stable around 200, which indicates the success of the algorithm. And I will use this video to show how it works. So at the beginning, the lunar lander doesn't land on the designated area well, and sometimes it's out of the zone and sometimes its leg touch the ground. However, when we increase the episode, the lunar lander can land within this designated area almost every time. This is the result for learning rate tuning. And when the alpha is very large, there is no convergence before 900 episode, and the reward is very low. However, for extremely small alpha, such as 0.00001, there is no convergence before 900, and the reward is below 0. When the alpha is in the order of 10 to the negative 3 to 10 to the negative 4, the reward could reach 200 within 900 episodes, which means 10 to the negative 3 to 10 to the negative 4 is the optimal value range. And the next hyperparameter is the epsilon. Epsilon leveraged the exploration and exploitation. A very small epsilon as 0.5 let the converged value to be very small, 0, because the randomness is too large and the optimal value could not be reached. With the increase of epsilon, the number of episodes needed to converge to the optimal value gets smaller. However, when the epsilon is too large, there is not enough exploration and it is possible to get stuck in local minima. Therefore, the optimal epsilon range is from 0.8 to 0.999. The next parameter is gamma, and we use 0.6, 0.7, 0.8, and 0.99. All of the gamma values enable to convergence as the optimal reward value. However, a large gamma as 0.99 yields a faster convergence compared with the smaller gamma value. The optimal gamma value therefore could be in a large range between 0.6 to 0.99. Because gamma is the decay rate of a reward from the final to the successful state, gamma should correspond to the size of the observation space, and a larger gamma could be used for big state space, and a small gamma could be used for smaller space. In this project, the size of the observation space is very large, so it makes a larger gamma a better choice. In conclusion, we used the Dowling double-DQN algorithm with prioritized experience replay, and it has proved to be a success algorithm in this project, with the converged rewards higher than 200. The optimal value range for the hyperparameters have been picked and discussed. Thank you.